Here we are at the bottom of page 13 with the solutions to number 13 through 16. So we're going to do number 13. 3x squared minus 12x plus 15. Better write that in there. F of x equals that. Now this 3 is going to come out of here, so I'm going to complete the square. So we're going to get f of x equals 3x squared minus 4x. Leave a little space. Plus 15. Now, take half of this as a negative 2 squared. So when we put a plus 4 in there, that'll make that a perfect square. Now notice we didn't just add 4 to this side of the equation. We added 3 times 4. So we have to add 12 over to that side. So when we write it, we get f of x equals 3x minus 2 squared. That thing got sucked up there, and then subtract 12, we get a plus 3. So it's going to look about like, let me see, we're going to take the original x squared function. Looks about like that. And we're going to move it 2 this way, then 3 up, and it's going to be 3 times as tall. So it's going to move 2 over, be 3 times as tall, like this, and then it's going to move 3 up. So the end result should look about right there and be really quite steep, like that. And round corner there on the bottom, it's not a V. So with the vertex, looks like the vertex will be, it was moved over 2 and up 3. So now, the y-intercept, that's a nice easy one. We could stick 0 in up here. 0 minus 0 plus 15. Stick 0 in everywhere for x. And now the x-intercepts, well, we're not going to have any. They should end up being imaginary numbers. Let's go ahead and try it. Normally, we would put 0 in for y, so we'd have 0 equals 3x minus 2 squared plus 3. Subtract 3 over. Divide that by that 3. So we get negative 1. So square root, and we get I. It's plus or minus. And then add 2 over. There's our x. So 2 plus or minus I. Now there's something that I wanted to show you on here. If you would have started from the very beginning, at the very beginning, and tried to find the x-intercepts by solving this equation, 0 equals 3x squared minus 12x plus 15, you could have done the quadratic formula. X equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. Now watch what happens to this guy right here. 144 minus 4 times 3 times 15. 4 times 3 times 15 is 180. So this guy ends up being x equals 12 plus or minus the square root of 144 minus 180. That is negative 36 all over 2 times 3 is 6. When this guy is negative, you can tell that we will get imaginary zeros. And that's the case. We get these imaginary zeros down here, that we will not have any x-intercepts. So this guy, as a review, that's called the discriminant. So you can tell just by punching in b squared minus 4ac that we would have had imaginary zeros. Let's check the calculator. So here we have 3x squared minus 12x plus 15, and put that on the graph. Now here's the zoomed out one. We can zoom normal and see what that looks like. And there we have it. Good. Number 14. Y equals negative 7x squared minus 11x plus 4. I'm not sensing any sort of nice factoring going on with a 7 and 11 and a 4. Oh, it might work, but I'm going to go straight to the quadratic formula. So we get for the y-intercepts, that's a nice one, 0, 4. For the x-intercept, we're going to stick in 0 for y and see what comes out. So we get 0 equals negative 7x squared minus 11x minus 4, plus 4, sorry. And the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. This gives 11 plus or minus the square root of 121 plus 4 times 7 is 112. So 121 plus 112, 233. I think that's not going to simplify too much over a negative 14. I'm going to write it a little bit different, negative 11/14 plus or minus the square root of 233 over 14. And you guys can stick that in your calculator, and you'll notice the negative sign on this one just went up and changed that to a minus plus, but we're all right. The graph now is going to look like this. Y-intercept 0, 4. It has negative 11/14, which will be about right here, plus a certain amount, and minus a certain amount. So it's going to look about like this. And the vertex is found by that guy. He's the one right in the middle between the two intercepts, also known as negative b over 2a. It's just part of that quadratic formula. So we have the vertex is at negative 11/14, and if we stick that into our calculator, let's punch it in, negative 7 times negative 11/14 squared minus 11 times 11/14, negative 11/14, plus 4. I'm going to punch that in my calculator. So here we have negative 7 times 11, negative 11/14 squared minus 11 times negative 11/14 plus 4. Enter. About 8.32. I'm going to put that as a decimal right there, 8.32. And let's go ahead and check it again to graph it on the calculator, make sure we got the right stuff. So here we have negative 7x squared minus 11x plus 4. Hit the graph button, and there we have it. Number 15. F of x equals 5x squared minus 3x plus 1. Get the y-intercept by sticking in 0. Get a 1 out, the x-intercept. Ooh. This one, we're going to have 0 equals 5x squared minus 3x plus 1. That doesn't look like it's factoring. Completing the square looks a little bit awkward. So I'm going to go with the quadratic formula again. X equals negative b plus or minus the square root of b squared minus 4 times a times c. And we get all over 2a. That's 3 plus or minus the square root of 9 minus 20. That's a negative 11 over 10. Wow, look at that. Our discriminant tells us exactly we are going to have imaginary roots. I squareds of 11 over 10. So, no x-intercepts whatsoever. Let's look and see what this looks like on the graph. We have 0, 1 is right here. X-intercept, cross that guy out. So we're going to head up from here. But where's the vertex? Now, in between these two imaginary numbers still, that negative b over 2a, you could do it right here, equals 3/10. So the vertex is going to be 3/10 something. So let's put this puppy in. 3/10 squared plus 1. And let's run it through the calculator. So here we have 5 times 3/10 squared minus 3 times 3/10 plus 1. And that becomes 0.55. So that would have been, we'll put it as 0.55. That could have been simplified down, 55 over 100. We get, what, 11/20. is what that might have come out to be. So over 3/10 up, oh, about right there. So it looks like that guy comes in and goes up about like that with no x-intercepts whatsoever. Double check on the calculator. We have 5x squared minus 3x plus 1. And we graph it, and there's a parabola right there. So finally, what does a negative, 0, or positive discriminant indicate about a parabola? So if we have x equals negative b plus or minus a square root of b squared minus 4ac all over 2a, here we have, if this guy is negative, that means we get imaginary zeros. Imaginary x-intercepts, so that's, we have no x-intercepts on it. Now, if this guy is a 0, so let's change that and make it a 0, then we get negative b over 2a plus 0 minus 0. This happens twice. That means we only have one root. The parabola is going to come down and just touch and then head back up like that because we only have one root. And then if we have a positive discriminant, so change it now to positive. If this guy's positive, we have two roots. So the parabola is going to go something like that with two distinct roots. If it's a perfect square, we get fractions, nice rational zeros. If it's not a perfect square and it has to stay under the square root, then we get irrational zeros. And that should do it.